The last strategy for solving systems equations is to solve by elimination. Now, there are a few situations where this method actually does save time. Even though graphing and substitution are very good methods, elimination may be used in a few specific situations. Now, of course, my expectation is that you're able to use all three methods relatively well. Graphically, well, that's because you're going to have to be able to graph. It doesn't matter whether you're going to take Foundations 20 or Pre-Calc 20, or their 30-level counterparts. You will have to know how to graph. At the same time, being able to do substitution is going to be a very good thing. Elimination, though, it really has a very strong relation to matrices. Now, I talked about that in section 2, but elimination is a very strong connection to what was the old B30 curriculum. So yes, you'll see that that's a 30-level course, but at the same time, it's the fundamental skills that were learned in grade 10. So our steps for solving a system is like so. We line up each variable and each constant over each other. We make the coefficient of either the x or the y the same by multiplying one or both equations by a number. Then we add or subtract, eliminate equations to eliminate a variable, solve, substitute, or eliminate to find the other variable. So there's multiple ways of doing this. So I will show this first example by two methods. Because it is math. There is more than one way of doing a math problem. So first things first, line up each variable and constant over each other. Well, let's see, the x's are right over each other, the y's are right over each other. The equals, which is actually one of the key aspects, the equal sign is also directly over each other. And then our numbers without the variables, which is the constant term, those are lined up right over each other. Now we're going to make the coefficient of either the x or the y the same by multiplying one or both equations by a number. Now I'm going to, again, I said that I was going to show this two ways. You choose which way you like, but again, it's just skill practice. So first things first, we want to do something with our coefficients. We want to make either the x or y the same number. Now you may notice here, for example, that the number, now we'll talk about in Pre-Calc 20, we'll talk about the absolute value of a number, but the actual number that is directly in front of the y are both 5. Absolutely, you also have to know that this is a negative 5y and this is a positive 5y. If you can't see that, you need to be practicing that kind of skill. That is back at grade 8 level. Now, the one way is, since they are already the same, I can go straight to step 3. Now we're going to add or subtract the equations to eliminate a variable. Well, if we want to eliminate something, now if we have that coefficient being the same, again, ignoring the negative and the positive, just for right now, this is just for right now, we notice that the 5's are the same. If we were to subtract these, so if we were to take this entire equation here and subtract this equation, well, please don't write this if you're writing 3x subtracting 4x, well, that's a negative 1x. Keeping in mind, you don't necessarily need to write the 1, but it's still good to understand that there is a 1. Negative 5y subtracting 5 is not 0, it's negative 10. And negative 9 subtracting 23. That looks a little bit weird. Negative 32. Not sure why that did that. Now you'll notice that we haven't actually eliminated anything here. There's still an x, there's still a y. Well, that's counterproductive. We can't do anything if we still have an x and a y. Same time, we'll talk about some skills in Pre-Calc 20 and Foundations 20 about how we kind of manipulate this a little bit, but we'll worry about that then. So since we have not actually eliminated anything, we're going to have to go with the other skill. In this case, adding the equations. And when I say adding, I am talking about taking this entire first equation and adding the entire second equation. Because here's what's going to happen. If I have 3x's and I add my 4x's, well, I have 7x's. If I have my negative 5y and I add my positive 5y, well, I have 0 y's. I don't have any y's to even write. My equal sign stays the same, and negative 9 adding 23 is 14. Now we have an equation, 7x equals 14. So I can just divide both sides by 7, and x equals 2. And now that x equals 2, well, we can plug it into one of our original equations, because we've already solved for one of the equations. Now we just substitute, or we could technically use elimination to solve for the other variable. Now, I'll show more of that substitution or show the other elimination in the other side of this. So now that x equals 2, I can take either of my equations. It doesn't matter. I could take my first equation or I could take my second equation. I'll just choose the first equation because it's the first equation on my mind. If you don't like dealing with negatives, we could have used the second one. But if x equals 2, x equals 2. Then we can subtract our 5y equals negative 9. So let's say 3 times 2 is 6. Oh, sorry. We can then subtract our 5y equals negative 9. Keep on solving. Subtract the 6 from both sides. Negative 5y is our negative 15. Divide by the negative 5 to get the y completely alone, which means that there is only a y by itself. And y equals 3, meaning the solution to this equation is 2, 3. It's where these two lines would cross. They would cross at the coordinate 2, 3. So again, just to put that into perspective, I don't know exactly what these two lines would actually look like because I haven't graphed them. But what I do know is that they're going to cross at the point 1, 2, 1, 2, 3. In some way, shape, or form, two lines, let's change color, are going to cross at that point. Maybe that actually look like they're crossing at that point. There we go. Now, they could be a positive slope and a negative slope. They could be two positive slopes. I don't know. I haven't solved them to get them into the y equals mx plus b form. I don't know what my slopes are. So now I'm going to solve this exact same equation, just I'm going to do it slightly different. 3x, subtract my 5y equals negative 9, and my 4x, add 5y equals 23. So now that we're lined up, we're all good, we're going to make the coefficient of either the x or the y the same by multiplying one or both equations by a number. Well, let's say we already eliminated the y's, so let's work with the x's this time. If we want to work with the x's, we want to try and get this coefficient of 3 and this coefficient of 4 to be the same. The only way we can do that, well, sorry, not the only way, but the shortest way is I would have to take this entire equation and multiply it by 4. I'd have to take this entire equation and multiply it by 3. Which means I'm going to have 2 brand new equations. Now, at the same time, they're not actually different equations. They are coincident or coincident. They're the same equations. Just this equation is going to be multiplied by 4. Well, it's going to be the exact same equation. But if I distribute my 4 in properly, and I multiply every single term by that 4, I'd have a 12x subtracting a 20y, and it would equal negative 36. Same time, I could take my 3 and multiply my 4x plus 5y equaling 23, distribute everything in, 3 by 4x is 12x, 3 by 5 is 15, 3 by 23 is 69. So here's what I can work with. Now that I've made my equations, or my coefficients the same, I can add or subtract to eliminate a variable. Well, no matter what, I'm not going to be able to get rid of these y's. If I add or subtract them, if I subtract them, I'm going to have negative 35y, and if I add them, I'm going to have negative 5y. But I can subtract this entire equation. Now, at the same time, it doesn't necessarily mean does not necessarily matter whether I take this top equation and subtract this bottom, or I take the bottom and subtract the top. It doesn't really matter. It's just the way that I have this set up. I can take my 12x and subtract 12x. Well, that's 0 x's. I don't have any x's to write. My negative 20y subtracting my 15y will be a negative 35y. And a negative 36 subtracting 69 will be a negative 105. And we just have to finish off our work. Get the y by itself. Divide by the negative 35. And y equals 3. Well, if y equals 3, I can then plug it into any of these equations. Let's see, on the other side, I plugged into the top one. Well, I'll plug this y into the second equation. 4x plus 5y equals 23. So 4 times x plus 5 times the y value is 3. So I'm going to plug 3 in for my y. Five times 3 is 15. Subtract my 15 over to get the x by itself. 4x equals 8. Divide by the 4. And x equals 2. So if x equals 2, y equals 3, our coordinates is 2, 3. The exact same thing as the left-hand method of solving. It doesn't matter which one you do. One person may do it one way, another person's going to do it another way. Well, it's all going to come out to be the exact same. The only thing you do have to be conscious and very cautious of is that all of your coordinates are always x comma y. Just because I solve for y first does not mean that that goes first. X comma y, the x value is always coming first. Even when we go into 3D space and we have a z plane, the x still comes first. But many of you will never have to deal with that. All right. Next equation. Oh, fantastic. Our x's are already the same. I'm only going to solve one method in the interest of time. But at the same time, it's the exact same skills. But let's just go back up to our steps to make sure that we have everything. Line up each variable and each constant over each other. Let's see, have we done that? 3x, 3x. Negative 2y, negative 4y. equals plus 13. They're not over each other. Shucks. Well, I guess we got to get one of them so that we have our variables x, variables y, and the constant terms lined up right over each other. I'm going to show you slightly differently. For example, I'm going to manipulate this equation. All I'm going to do is subtract my 1 over. This is another way that some people do it. So if I subtract my 1 over, my top equation becomes 3x, subtract 2y, subtract 1 equals 0. Why did I do that? Well, it allows me to see this. Now that I've completely manipulated this equation, I'm not working with that equation. I'm working with these two equations. Yes, it's still a viable equation. Just I'm going to cross it off because it's not needed anymore. I've manipulated it to give me this. Again, you'll notice that this looks different than the equations that are in example 1. It has an equal to a number. I'm just saying this is another method that some people do. They have the number over to the left-hand side. They have the 0 on the right-hand side. Same time, this having something equal to 0, which makes it into which form? Give you 3 seconds. General form, because we have a positive x, all of our coefficients are integers, and it is equal to 0. Now that we have everything like that, sorry, I'm going to try and make my notes look a little bit nice. I'm going to do some subtraction. Why am I going to subtract? Well, the only reason I'm going to subtract is my coefficients are the same. I kind of skipped that step, sorry. Make the coefficient of either x or y the same by multiplying one or both equations by a number. Well, the x's are already the same. They're already 3's. Well, the only way that I can eliminate them is by subtracting. If I have my 3x and I subtract 3x, I have 0 x's. I'm okay. Negative 4y subtracting negative 2y, that is not 6. That is not 6. Negative 4 subtracting negative 2 is negative 2y. 13 subtracting negative 1 is positive 14. Now I have a nice equation that I can solve for my y, because that is my next equation, next step. I've already added, subtracted. Now I just have to solve. So I can subtract my 14. Negative 2y is negative 14. Divide by the negative 2. And y is 7. There's no question mark. It's just y equals 7. Not y is 7. Hopefully I got a groan or eye roll out of someone. All right, so y is 7. So it doesn't matter which equation I use. Just for shoots and giggles, let's use the top equation that we manipulated. 3x subtracting 2y equals 1. 3x subtract 2, the y is 7. So if I continue on, 3x subtract 14 equals 1. Add 14. Three x equals 15. Divided by the 3. And x equals 5. If you write it like this, you are wrong. All coordinates go x comma y. You do not go y comma x. You do not put it in order of the way that you solved it. All coordinates, all of our solutions, goes x comma y. Two more quick questions. So let's keep on going. So here we have an equation. Let's see, our x's are lined up, our y's are lined up, our constant term, our zeros. Fantastic, they're all lined up perfectly. Next step is to get one of our coefficients the same. Let's see, we've gotten rid of a lot of x's. So let's get rid of our y's. Well, if we want to get rid of the y's, I'm going to have to make the numbers the same. So let's see, I can multiply this one by 4, and I can multiply this equation by 3. 4 times 2x is 8x. 4 times positive 3y is positive 12y. 4 by negative 8, negative 32. 4 times 0 is still 0. 3 by 5 is 15. 3 by negative 4, negative 12y. And 3 by 6, 18. 3 by 0, still 0. Now, which method is going to actually make sense to get rid of these y's? The next step is to add or subtract. Well, if I want to add or subtract something, just again, because of how I set it up, I'll take my top equation, subtract my bottom. I could go the other way. Sorry, not subtract, sorry. But I would need to eliminate one of the equations. Well, in order to do it, the best way is adding. Because that is going to be the only way that I can take 12 and eliminate a negative 12. 8x add 15, 23x. 12y adding negative 12y is 0. Negative 32, add 18. Should be positive 14. That is not right, sorry. Wow. This is what happens when you don't actually use your calculator. Negative 14. At the same time, that's also what happens when you're trying to do this on a little bit less sleep. So make sure you still get a good night's sleep. You still get good rest. That is one of your responsibilities. If you're on your phone until 2 o'clock in the morning and you're complaining about having to do your schoolwork, well, that's kind of on you. So, last thing, we want to get our x's by itself. So, 23x, I added my 14 over, 14. I can divide by my 23, and x equals 14/23. Not the end of the world. Not the end of the world. That means I just have a fraction. Fractions are not your enemy. What is your enemy? Ignorance. Not trying something just because you think it looks hard. Try it. Obviously, if it's going to be something that's going to put you at risk, maybe take a step back. But working with fractions, as long as you're not trying to deal with something that's going to be highly volatile and dealing with the fractions is going to be literally explosive, please don't go that way. But if we're dealing with a math equation, fractions are good. So I can take 2, plug my 14/23 in. And continue on. Let's see, sorry, I'm sticking with blue. So that's 28/23. Sorry, it should just make sure you remember the skills. 2 is the same as 2 over 1, multiplying fractions. 2 by 14 is 28, 1 by 23 is 23. Not just in the interest of space, I'm going to bring all of my work up here. Now, because I actually have a Smart document, I can pretty much actually do that. I can actually bring everything up just so I have more space. I know that some of you aren't, but at the same time, if you have a paper copy, you are able to still write small, and an arrow showing where your next step of work is perfectly fine. As long as you're not trying to go left, right, up, down, left, 6 into the 16th dimension and then back again, you're okay. But we want to get our y by itself. We want to solve for our y. So I'm going to subtract a 28/23 and add an 8 over. So if I add an 8 over and I subtract a 28/23, I'll have my y term by itself. Of course, I can't add these, not as they are. In order to add my fractions, I need a common denominator. Well, in order to get that common denominator, I'm going to multiply this by a funky form of 1, which means I'm going to multiply it by 23 over 23, giving me 100, oh, maybe I should write 3y, 184 over 23. Therefore, I can actually do some things. 184 over 23, subtracting 28 over 23 is 161. And to get the y by itself, I divide by 3. Well, again, another way of writing divide is dividing by 3. Well, how do you divide by 3? How do you deal with a fraction and divide by something? See, my 3's cancel off on my left-hand side, leaving me with just the y. And I can have my 161 over 23, dividing by 3, which means multiplying by 1/3. Giving me y equal to 161 over 69, coordinate 14/23, 161 over 69. Personally, I absolutely love for you to do this. This is usually worth 1 mark on every single one of my assignments. Writing down your solution, writing down your answer. And of course, as I keep on going, I realize that this is not really the greatest because for sure 184 subtracting 28 does not give you an odd number. That's totally wrong. I have no idea what I was dealing with in my head. This should be 156. Oh, wow. So get rid of a couple of these 161s. The answer is going to be different. It's okay to make mistakes. That's why we also go back, check our work, make sure we have enough practice, make sure we have enough sleep. Same time, if you have a little one and you're not really privy to that beautiful slumber, it can get a little bit difficult. Anyways, okay, 156 and 3 can actually reduce 152. So now we have a number that actually works. I'm fine with making mistakes. It's being able to go back and check your work, making sure that whatever you're doing, you can justify it. Because as soon as I get an answer I have to double check and make sure that every single one of my steps are correct. I go over my work again. We are all human, unless you're watching this in the year, I don't know, 30, 40, and you're some kind of cyborg. Cool. Continuing on. Ooh, fractions. Are fractions the end of the world? If you're saying yes, then we gotta have a talk. Well, absolutely working with these fractions, especially 2/3, 1/2, 1/4, 5/2, it's not going to be the nicest to work with. At the same time, we can still do things. We can still work with it. Because a beautiful thing is to work with fractions is we can actually eliminate our fractions. Well, in order to get rid of a 3 as our denominator and 2 as our denominator, I can multiply every single term right there by 6. If I distribute my 6 in, 6 by 2/3, again, just recalling those skills, 6 by 2/3, 12/3 is 4. Our fraction is going to be eliminated. We have 4x. 6 by 1/2, 3. 6 by 4, 24. I can also do the exact same type of thing here. Well, I can multiply everything here by 4. 4 by 1/2 is 2x. 4 by 1/4, 1. 4 by 5/2, say 20, 10. Now we don't have any fractions. But at the same time, this fraction or that equation and that equation are the exact same. This equation and this equation are the exact same. They are coincident. They are the exact same equation. And since they're the exact same equation, they would be literally the same line, wherever it is, whether it's positive, negative, however it is. But here's our issue. We don't have anything to eliminate yet, which means that we're going to have to take one of our equations and multiply it by something to get rid of one of our variables. It doesn't matter which one we're working with. So let's see, what did we do in the last equation? We eliminated our y's. So let's eliminate our x's in this one. Hopefully you know that if you wanted to eliminate your y's, you just have to multiply probably this bottom equation by 3. And then, say this would be, just so you know, that would become a 3. So how can you get rid of a negative 3y and a positive 3y? Hopefully you answer add. So I'll just erase that. If I want to get rid of it, it's potential that you could say multiply everything here by half, but then you're dealing with another fraction. And some of you don't like dealing with fractions. Absolutely, whole numbers are nice to work with. Fractions are not the end of the world. But I can still multiply every single one of these bottom things by 2. Meaning I have 2 new equations. Sorry, not new, but just they look different. Now I totally understand that some of you may look at this like, do I have to do this? Some of you may choose to just write down the other equation. Again, as I've said multiple times already, it doesn't matter whether I'm eliminating one equation from the other or taking this, that, or the other thing. It doesn't matter that I'm taking this equation and subtracting this one in this step, but then I switch it around in this step. It's the exact same thing, but I can still subtract. See, I'm done with everything above this blue line now. I'm not even looking at it. It's just complete blocked out. Just say, let's see, change my settings slightly. Fill. No. There. Can't even see it. There's nothing there. So I can do the rest of this in peace. Now, I'm not saying that when you're doing questions that you completely scratch everything out. Do not do that. Because you still have to show your work. I mark process, I mark work. You can do that. But I can still eliminate here. My 4x subtracting my 4x, well, I have 0 x's. 2 subtracting negative 3y is 5y. 20 subtracting 24 is negative 4. Get the y by itself by dividing by 5, and y equals negative 4/5. Now, the reason that I don't actually scratch everything out here is because I'm going to need to go back and find out what is my y. Sure, I already know what my y is. I need to find out what is x. So I'm going to have to use one of these equations to solve for my x. Let's see, I was working, manipulate this one. It doesn't matter which one. You could technically plug your y into here. But if you don't like working with fractions, why work with fractions? Again, my emphasis is you need to know how to work with fractions so that when you do need to, you can. You don't have any kind of panic attack because you're working with a fraction. Say, yeah, I'll choose this one. Say 4x subtract 3y equals 24. My y value is negative 4/5. And we can go from there. 4x plus 12/5 because 3 is the same as 3 over 1. And I have to subtract my 12/5 over to get my x by itself. I can't subtract fractions without a common denominator. So I get my common denominator. Multiplying by a funky form of 1. And what do we get? 4x equal to 108 over 5. Divide by 4. Well, dividing by 4 means multiplying by 1/4. I'm pretty sure I can reduce these. Say 4 goes into 4 once, 4 goes into 108 27 times, which means x should be 27/5. And since x equals 27/5, I'm going to write down my answer. 27/5, comma, negative 4/5. And there's our answer. I'm always visually going back, double checking my work. And yes, we're good. Now, if you do have your textbook, absolutely, these are some fantastic questions. I do have supplemental questions for you to practice so you can make sure you have these skills. And again, we are limited on the fraction questions. But at the same time, you can still have a good understanding of everything without the fractions. Just like on the first page. For absolute mastery, having an understanding with the fractions will be great.